Okay, so again, just to recap, when two lines are perpendicular, the slopes are inverse reciprocals. For example, line one has a slope of 2, then line 2, assuming it's perpendicular to line 1, we have a slope of -1/2. Also, you could probably, I mean, it's pretty obvious, but you may want to state this because it's kind of why they're perpendicular. Also, the lines form what kind of angle? Yeah, lines form a right angle. Or 90 degrees. Okay, now what about parallel lines? Good, Ale? Yeah, good. Yes, I agree. So what I'm going to say for that one, we'll change colors for a bit of contrast. Slopes are identical. This should happen because the lines never touch. So they rise and run the same way. Are you guys figuring it out, by the way? Okay, we'll do it later. That's okay. We'll do it later. That's fine. That's fine. Thank you, Reagan, for trying to help. I appreciate it. So yeah, slopes are identical. This should happen because the lines never touch, so they rise and run the same way. Yeah, so I think I kind of said all I need to say for that one. I don't think I have to say any more about that. Okay, so that was the observation from the little activity. Now let's do the algebra. This is where we're actually going to go around the room and kind of answer questions. I'll help you guys out if you guys get stuck. So let's start with I'll start with that table off to the far right. So Peter, can you read number 1, please? Okay, so for part A, so look, we have 1/3, right? So if I flip it and change the sign, so what do you think it would be, Peter, if I flip it and change the sign? That's it. So we'll kind of go around. So Reagan, if I took B and flipped it and changed the sign, what would I get? For part B. So I want to flip the fraction. 4/5, there we go. Yep, just flip it and change the sign. Now, if you don't see a fraction, make it a fraction. If you make it a fraction, what's beneath it? 1. So Zoe, how about that one? If I flip it and change the sign. Perfect, -1/2. There we go. Okay, we'll go in the back. Colette, how about, so that's like -1/1. So if I flip and change the sign, what do I get? This one, yep. Now this is a fun one. Faith, I'll give you this one. If that's 0, what happens if I flip that? Well, you get 1/0. Or you can put -1/0 if you want. But here's the problem. Can we divide by 0? We can't. So we say undefined. We say undefined. And the reason we can't divide by 0 is if you think about standard division, right? Like 10 divided by 2. You don't have to write this down. But what if you had 10 divided by 2? I know it's 5. Why? That's because 10 equals 2 times 5. I could take the denominator, multiply to the other side, and it would be a true statement, right? I know that. Here's the problem. Let's say I have 10 divided by 0. I'll put a little question mark here. So 10 will equal 0 times a question mark. So can I multiply a number by 0 and get 10? It's impossible. I cannot multiply something with 0 and get 10. Anything times 0 is going to be 0 because the way we learned about multiplication back in the day, like maybe if you think about 2nd or 3rd grade, whenever you guys cover it, I should know this actually my son's in 3rd grade. I should know this, but if you have like 2 groups of 5, right? Or 5 groups of 2, but here you got all these groups of nothing or no groups of something. It just can't happen. That's why there's no definition. So we say undefined. So be careful about that. And by the way, if the slope of a line is 0, what kind of line would that be if the slope is 0? If you think about rise or run, just flat, right? Think of it, just flat. So if it's perpendicular, it's going to look like this. Think about it. This has all this rise, but no run. So there's no change in x. You're divided by 0. Hence, that would be an undefined slope. So E itself, slope of 0 is horizontal. The perpendicular, of course, would be vertical. All right, we'll keep on moving. Ale, can you read number 2, please? So now if it's parallel, what do we expect the slope to be? The same. What's the slope right now? So we're going to use the same one. Y equals 4x plus b. Now, I have to solve for b. What did I do to solve for b? Plug it in. Exactly. Thank you. So plug in 8 and x, 8 for x and 3 for y, and solve for b. And that should be pretty simple. You should get negative 29, I think. Yeah. So we get negative 29. And there we go. Y equals 4x minus 29. Yeah, because we see that now. We understand it. It makes sense. It makes sense to us. All right, let's look at number 3. Cam, can you read number 3, please? Perfect. So what's the slope of, so that's still a slope of 4, but if I want perpendicular, so what happens if I flip and change sign? Yes, negative 1/4. Awesome. And same thing, y equals negative 1/4 x plus b. And solve for b. Plug in 3 for y, 8 for x. So 3 equals negative 1/4 times 8. What's b going to equal? Close. You want to be careful with the negatives, right? Should I add 2 or subtract 2 to both sides? Yeah, b is 5, correct. And careless errors, just so you know, I'm very forgiving of careless errors. It happens. I mean, I made some mistakes today. My pre-calculus class, I always make mistakes. But try to catch yourself if you can. Like, look back your work, check your work, make sure it makes sense. Like, if I plug in 8 and 3 into my final answer, it makes sense, right? I'm like, cool. Negative 1/4 of 8 is 2. Negative 2 plus 5 is 3. Cool. But see, that careless mistake pyramid, if you have 1, negative 1/4 x plus 1, if I plug in 8 and 3, wouldn't make sense, right? Because that's negative 2 plus 1 is negative 1, not 3. Like, what's wrong? How come it's not working? Oh my God, I added 2. Sorry, subtract instead of added 2. It happens. It happens. But you gotta check your work. That's how you hopefully can avoid careless mistakes. Okay, and let's go to this table. Simeon, can you read number 4, please? That's kind of weird a little bit. So what I like to do is do a sketch for these kind of when they say x equals y equals, so there's no mx plus b, right? It's straight up vertical or horizontal. X equals negative 4. It's confusing because I see x, I think of horizontal coordinates, but x equals negative 4 is actually up and down. Of course, x is negative 4, of course, but there's no y. Remember, we talked about line equations being relationships, right? There is no y, so it means y is a free for all. We can do whatever we want for y. There's no restriction on it. The only condition, x must be negative 4. If x must be negative 4, guess what? Negative 4 up and down, right? Up this way, down that way. It's got to be vertical. 100%, it's got to be vertical. Now, it's got to be parallel to that line. So it's not going to touch it. And it's going to pass through what point? A3. Yes, A3. So I'm not going to write tick marks. It's going to be lazy. A3. So I want to be perpendicular to that blue line. So my line's going to be straight up and down again. It's passing through what coordinate on the x-axis? So what I'm going to say my equation is then? X equals 8, because that's true. X does equal 8. That's how you say it. Some people try to memorize, and trust me, I've seen people really mess this up because they focus on memorization. And I get it. You guys have to stick to the class. You got other things in life. This is not important. It's not terribly important for the grand scheme of things like, but I want you to get it right. Understand. Just draw. Do yourself a favor. Just draw. You draw it. I know you can do this. I know you can do this. And just state the right equation. Because then you're like, is it y, is it x? I don't know. Like parallel, perpendicular, like your mind gets all jumbled. Just draw and keep it straight. So now, let's try it again for the next one. Same thing, x equals negative 4. But now I'm what? Parallel, perpendicular. Find how to use a purple line for perpendicular. So that sounds the same. Playing words there. So in this case, x can be whatever we want it to be. There's no restriction for x, but y clearly has to be what value?
3.
So y equals 3. That's how you say it. That's how you write it. Y equals 3. So the drawing like literally took me like 10 seconds. Didn't take very long. Okay. Let's keep moving so we can get this done, and then we'll move on to the next set of notes. All right. Maggie, can you read 172, please, part A?
Now that you know more about the slopes of parallel and perpendicular lines, A, consider the triangle shown such that P 2.5, 3.5, Q 1, 3, R 0, 1, P 4, 5, 2, 5, Q 5, 1, R prime 4, -1. Use your ruler to draw 3 near dashed lines. 1 from P to P prime, 2 from Q to Q prime, 3 from R to R prime.
Thank you.
What is the relationship of these dashed lines? Using knowledge of slope to verify your observation.
So I think we kind of did this. But did we do this? We did actually. Okay. Well, if you didn't, if you think about it, here I drew a purple and a pink line. And I'll call this dot in the middle A. So it's pretty clear the purple and the pink should be equal to each other. So the relationship should be PA equals P prime A. I don't have to draw the segment symbol because I'm just when I don't draw a segment symbol, I'm assuming the distance of PA equals the distance of P prime A. If you do draw the geometric symbol, then you have to use the symbol, the tilde atop of the equal sign that's congruent. It's kind of just one of those nuances of geometry. And we'll do more of that later. But if you're saying that a geometric shape equals another geometric shape, you have to use congruent. So segment PA is congruent to segment P prime A. If you want to use a ruler again to keep it all straight, so I'll do orange. And I'll do black, Spirit of the Giants, and Halloween. Can't believe Halloween stuff's already out in stores. That's nuts. Yeah, my kids are getting excited about that. So that's QB is congruent to Q prime B. Yeah, correct. And then lastly, for I'll call the C right here. I'll do like, I don't know what the color that is, like maroon and dark blue. Those are also the same. I'll call it C. So RC. Yeah, Kira, go ahead. You have a question?
Wait, the thing on top of the equation symbol that's squiggly.
Yeah, it's a squiggly line. Yeah. It's a tilde. And that, so yeah. We'll call it squiggly line, I don't care. Squiggly line, equal sign, that means congruent. So no, that would be two squiggly lines. That'd be that. So for example, people say pi, there's another squiggly line on top of pi. It's congruent to 3.14 because pi just goes on forever. So we truncate that for 2 digits. Or sorry, 2 decimal places. So, but the tilde of the equal means congruent. So you do that for shapes when shapes are the same. Okay, so then why don't you guys in your table groups briefly discuss B and C. Think about what you want to say about that. We'll confer in about 2 or 3 minutes. Then we'll move on to 1.2.4. So in your table groups, just talk about parts B and C.
Okay.
Let's try to come up with an answer for that one. Sure, yeah, go for it.
Okay, so Yeah, yeah. And then it's missing. Is it talking about these? No, oh, yeah, I think it's funny. Thank you. Are we taking your test today?
The quiz, yes, we'll do the last 15 or so minutes.
How many questions?
Great. Yeah, I'll talk about it in a moment.
Well, we have another one, or is this our last one?
It's the last one for a test. The test will be on September. The test is more we call it a quest. It's like a large quiz. And of course,
On summer stuff?
yeah, some stuff, yeah.
So. And this too, or?
All the brief discussion.
Yeah,
I'm gonna type up some stuff here. Actually, I'll show you the answer key. Not just yet. No, we'll discuss.
Yeah, the writing stuff. Okay.
All right, let's briefly discuss here. Okay. For part B, focus on the issue between a line of reflection, each of the segments connecting with this image. So they're perpendicular, right? We saw that. If I go back up here, when I click Q to Q prime, Q to Q prime, R prime, they're perpendicular to line L. So the dashed lines are perpendicular to the line of reflection for a 90-degree angle. The distance between P, Q, and R and the line of reflection is the same. We said that already. So like we did PA, P prime A, RB, or QB, Q prime B, and of course RC, R prime C. So we know that now. That's just restating what we've already deduced. Then for C, use slope to confirm that the line of reflection is perpendicular to the segments connecting each of them. So slope of the line of reflection, if you kind of try to look at points on there, hopefully this seems pretty reasonable. The dash, or line L, they're all dashed, I guess, or say it's dotted. You go up to right 1, so that's the slope of 2. Now the other one's P to P prime, Q to Q prime, R to R prime. Like that's 0, 1, and that's 4, -1. That's 1, 3. That's 5, 1. That's 2.5, 2.5, 4.5, 2.5. If you were to find those slopes, so I'm not sure if anyone did that, but that's okay if you didn't. But if you actually were to go through the process of calculating the slopes of P to P prime, Q to Q prime, R to R prime, each of those slopes will be -1/2. If you actually were to go through those calculations and do that, rise over run. And of course, the slope of line of reflection is 2. Hence, if slopes are negative reciprocals of each other, or inverse reciprocals, that's what they say. I say negative reciprocal for perpendicular, but if you say inverse reciprocal, that's how they do in CPM. That's going to indicate that they're perpendicular. That proves it. So line of reflection had a slope of 2, but the slopes for P to P prime, Q to Q prime, or R to R prime were each -1/2. Hence, you have inverse reciprocal. Oh, go ahead. Sure, of course. Yeah, no problem. Hence, you have perpendicular lines. So now let's move on to 1.2.4. We'll spend maybe 10-ish minutes on it, maybe 12 minutes, and then probably won't be able to finish up, but we'll definitely wrap it up on Tuesday. I don't see you guys again until Tuesday. And I do need to get out tracing paper again. So what we're gonna do is trace these images using these rotations. So it says here, actually, I'll have someone else read. Blake, can you read the instructions on top page 1 of the new notes?
Consider what about function that produces the shape of our point. Does it make any difference if function is clockwise versus counterclockwise? If so, what does it matter? Are there any circumstances when it does not matter? Are there any situations when the rotating image is not as exactly on the original shape? Investigate these questions as you wish to appreciate the flow about the example.
Great, thank you so much. So let's use some tracing paper. So let me, we have the pivot points as you see right there. Look around, give you guys a couple sheets of this handwritten or parchment paper. And you guys, we're gonna do the same thing that we did the other day. That was on Tuesday. Keep me on the page. And yeah, you're just gonna rotate according to what they say. So for the first rotation, that's 180 clockwise. I mean, if you go 180 counterclockwise, I don't think that would matter. Would. But yeah, like for B, that'll be 180 counterclockwise. Obviously, we do 90-degree rotation. Do want to be mindful whether you're going counterclockwise or clockwise. Yeah, so we'll go through these and we'll compare. Yeah, let me lower the fan. It's going to take this fly. I'll come around and help you guys out if you're having some trouble doing the rotation. And one thing that might help, actually, I will admit I did a better job with it with my E period because it helps me do the second time around. Is it might help to your pen or pencil have that rest on the pivot point and then rotate the paper whichever direction you have to rotate it. But remember, you gotta trace it first and then do the rotation. You gotta trace it first, then do the rotation. So for example, for this one, and again, what you want to do, in case you guys forgot, probably drawing a cross. Trace image. Then rotate 180. So it'd be kind of like that. And then draw the new image. And compare, call me over. Back. Yeah, got it, yeah. Keep going, be great. That's you didn't quite go all along, so it's so good, you traced it. Yeah. I don't think that's it. So we'll leave that as for the time, and then you rotate like. Now you're gonna trace that, so it's kind of hard.
Yeah.
Kind of like
Yeah.
do that, but yeah, that's how it looks. Yeah, so let's take a few minutes to do that, and then I'll show you. Okay, I'm gonna put up the answers so you guys can see. Any questions so far? Okay. Oh, back to 75-minute classes. That's good. Amazing. No. Any questions about A, B, C, or D? And by the way, they're exactly the same for A and B, because 180, if you turn around 180 and then turn around 180 the other way, like if I turn on 180 this way, 180 the other way, or whatever, right? I get back to the same place. So it doesn't matter. Obviously 90 one way, 190 the other way, you get different images. 270 is very similar to D, because you're getting 270 clockwise compared to 90 counterclockwise, they end in the same place. Obviously 360, you go around once. G, just given the way N is written, as well as a square. So G is the same. If you do 180, you get to the same orientation. For a square, because you have four corners and you have four equal sides, four equal angles, yeah, you get the same thing. So it shouldn't matter if you trace it. Okay, I don't know think I want to get to this pages 2 and 3. I think we could do this on Tuesday and do the next lesson. Because I don't want to really rush it, and I really want you guys to do the quiz. So we can save the rest of these notes for Tuesday because we have 75-minute periods. We'll do the quiz. 3 questions. So just solving system of equations. Hopefully you guys like if I had I'll give you something very simple. It's a little too easy. So you can do substitution or elimination. If you substitute, you have to get one of the letters by themselves in terms of the other, and then substitute into the other equation. Or you do elimination. If I had 2 equations, what happens to the y's? So 2x equals 4, x equals 2. And y equals 3 afterwards. Of course, that's a very simple situation. If I had and again, I don't know how this would work out, they didn't work out the numbers, but if I did something like this here, if I had that, then what do you think I would do at this point? Faith, go ahead. Yeah, by something, right? You can do 2 or 3, depending on what you want to get rid of. Yeah, if you want to get rid of the y's, then 3 would make sense. And then you have 3x minus 3y equals negative, and add them afterwards. Or if you don't want to do elimination, you can do substitution still. Get x by itself in the second equation, substitute in the other. That works. If I have something like this here and how to solve it, so if I can't factor it and I give you the quadratic formula, what do I substitute for each of these letters? I think we just talked about it not too long ago in the homework. What is A, B, and C here? Go, Faith. You just throw it in and work it out. Correct. And if you need a calculator, you totally could use one. Now I have spare ones if you need one. And then lastly, what was the other one? I couldn't blank. Oh, wait, no. What? Right here. Oh, You guys remember how to foil? First outside into last? Yeah, so, okay, cool, let's do it. Again, different versions. Oh, you're not doing that. You want to do the first one still, not that one? Okay, that's fine, that's fine. No, that's what I said. You can probably just get another one.
Yeah.
Yeah, and actually, you can talk about the rest of, actually, I'll link that, let's take care of that, the rest of the notes. The 1.2, yeah, let me talk about that with you. There's still some parts 1.22 I want to talk about with you. You know, it's that here, hold on. Yeah, what's up? Not quite. Yep, well. Yeah, so I'll come to that soon. Was that? What was that? Yeah, just means you want it fully expanded. So you need a foil. Right. Okay, so yeah, so I know we were, it was like the odds and all sorts, but we did reflections, then we plugged it again, we noticed that this is the same one that exists, just shift the right. And then this one for part D, yeah, good. Yeah, it's the same, but it's obviously going left and right and out or diagonally, whatever. Right? And then right, translation is a type of transformation, so this is hierarchy, not hierarchy, but is category. So transformation is some double term, but reflection, translation, translation. Dilation will do later. This, not sure if we'll do this. Maybe it will do this. That's when you shrink or expand. Spectrum very fast. And here, what we did, we first reflected setting count and how far F was from the long reflection and create other points. Then the way I did this one, this reflection, is that kind of for itself or G over around you and then or E. Use count it. One, two. Oh, you go the same direction to the right.
Yeah.
Yeah, so if you're going down, you go right.
Yeah.
So 1, 2, 3, 6, 8. So I go 8 to the right. 1, 2, 7. So it's up perfectly. Then you do the same thing with that. Or if you think about it, just go 8 down. These are problems. Then what we can do is recognize that, well, if I when we trace this, four positives, and rotate it 90 degrees, the back this way. So that's where we're noticing this rotation that broke that this situation, because I think this is 45 degrees, if I'm not mistaken. That you have these two reflecting lines, or reflection lines that are 4 and 45 degrees when I rotate it. It's kind of like reflecting 3 over there. So when I do that, your expression, you don't have. So we do the same for this one. But for that. And I went 90 degrees counterclockwise. So we did that. Yeah, and then here. Same thing again, we'll draw those. Mercury. Maybe. So we see these all. And this one you could say, hey, let's dump it over. Exodus me. Now like this. And shift down 2 weeks. Or you can shift to right, we talked about this line. And then go down to, so that's over. And that's pretty much oh, we did talk about this too. Right. Yeah, here we talked about what draw that. So we see that A and B prime are equal, this is that B and B prime are prime. So that's what I did first. And it's also A, B, C statements. This one here, the slope of this line is going to be this, which also make the same slope. And if I go up 5, I have to add 5. That's why it's +1. And then to do the perpendicular, I can place this. And rotate 90 minutes. Actually, I think we're supposed to be. About the order. Oh, 90 degrees. Well. Yeah. Seems a lot, that's okay. I don't want to worry, but actually it's supposed to go 90 degrees. Yeah, your graph's a lot, it's actually more like this.
Yeah.
That's okay. But that would be the equation of that one. And you see notice the slope is flipped, and the sign changes. Those are probably that's what it is. So those are the things you missed. So I think I should get you caught up for the most part. And if you have any questions at all, you can just good.
Homework 4.
Yeah. Homework. Well, homework 3 was this back here. You know, that was one to finish doing those problems. So it's like problems like 3. Yeah. So it's gonna be definitely number 3 here. Those are the 2 parts. Which one of those? Yeah. There's 3, 6, 7. 5. And 11. And there's
And I think it's. And I would like to take the first one.
sure, great, first 2.
Yeah.
Great, perfect. Yeah, so do that, and then there's obviously another one that's due. So if they've had the long weekend, so
Yeah.
you'll be caught up by now. Yeah, great, great.
Can I go to the bathroom?
Thanks, appreciate it. Homework's already been posted to Schoology. It's just a bunch of stuff in the CPM textbook, but I did put a PDF. Yeah, yeah, there you go. Yeah, if you can simplify the answer, if you want, I did ask for this one. If not. Oh, yeah. No. Oh, of course, yeah. Yeah, sure. Sure, yeah, yeah. You get the answer. This is. Correct, yeah, correct. Yeah. So good. You do better? Good, awesome.
Answer. I mean, I'm more than happy.
Correct, right. Good. Mhm. Yeah, then once, hold on a sec. Just trying to understand your work here. Oh, yes, once you get what X is, you throw it back into one of the equations, solve for Y, correct? Yeah. But one thing I will caution you about, Maggie, you have a really weird fraction, right?
Yeah.
Okay, I try to make fractions not weird. Or pretty clean. So you may have made, double check your arithmetic to see if there should be a plus or a minus. Like notice you multiply the second equation by -1, right? Notice the second equation you multiply by -1. Okay, did you multiply everything by -1? Yeah, there you go. Well, you're still recording, really. Yeah, I had known how like all this like light blue stuff. That's kind of cool. Hey, sup?
Kind of confused. Is this like?
Sure. Yeah, that's what I want. Yeah.
That's what you want?
Yeah,
Okay.
sure, yeah.
Thank you.
Yeah.